this is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 6-4 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to write a recursive formula for a sequence. I'm going to pop this in here and say a geometric sequence, because as we learned in our last example, there's two types of sequences, geometric and arithmetic. Alright, so this formula specifically is for the geometric kind. Alrighty, so let's talk about what it means for something to recur. Alright, if I'm sitting in my English class and I tell you that, yes, this class is a recurring class, you tell me that means it happens over and over again. Okay, so a recursive formula is one which we apply over and over and over again. So when we talk about a recursive formula, there's a little bit of vocab that's kind of nice to know. The first way that I do it, when I go to read a recursive formula, there's some English ways to read it, all right? This is called a sub n. All right, this is the nth term in the sequence. Okay, I use it to think of this term. If ever I want to talk about the term that happens before this term, I talk about a sub n minus 1. I use that to say the previous term. And if I want to talk about the next term, well, then I would use a sub n plus 1. And so what we're doing with this recursive formula is we are describing one of these numbers relative to the numbers around it. So I'm describing 27 either in terms of 18 or in terms of the 40.5. All right? And that's what's important about recursive formulas. Now, usually, because we're applying this formula repeatedly, usually we use it to talk about the previous term, but sometimes people get a little wild and use the next term notation. Savvas uses the previous term to describe things. So that's the formula that they have here. So with a recursive formula, to find this term, you take the common ratio and multiply it times the previous term. Isn't that what we were doing on our last example? Wasn't that how we were figuring out if it was a geometric thing? We were figuring out what it multiplied by? Yes, that's just the same thing. Now, recursive formulas are super, super helpful in computer programming. So what I've done is down here at the bottom of the screen, I have included this GIF. Those of you guys that don't know, this is a game called Mortal Kombat. And so there's this character here in the red, his name's Liu Kang, and he's doing what is called a spinning bicycle kick onto Reptile. So each time he kicks Reptile, my GIF's a little slow, but do you see how it kind of chunks down? It doesn't just do one smooth slide, it goes dot, 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 every time Reptile takes damage. So a recursive formula is used to program Reptile's life when Liu Kang does his spinning bicycle kick. Kind of a neat fact there. So let's go ahead and let's write our recursive formula. Alrighty? So to start with, we need to figure out what our R is, or our common ratio. Now, if you know that this is already a geometric sequence, you don't have to do multiple iterations of dividing. You can just take one term and divide it by its previous term. In this case, I get 12 divided by 8, and 12 eighths. Those are both divisible by 4. That's 3 halves. All right, so that is my R value. And so I'm just going to plug into this formula exactly how you see it. So a sub n, so to find this term, I'm going to take r, which is 3/2, and multiply it times the previous term. There you are, that's the formula. Now the thing about recursive formulas is you have to know where you're starting from because they're building on itself, right? So what you have to do is you have to start by saying what a sub 1 is. All right? So the formula is useless unless you specifically state what the initial condition is. What is the initial value that you are starting with that you're multiplying by that 3/2 over and over? So in this case, my a sub 1 is 8. And together, this is the entirety of the formula, which is actually two formulas. It can be a little confusing. Let's try it again. Alrighty, so I'm going to start by figuring out that r value, or that common ratio is what it's called. So to figure out my common ratio, I'm just going to take a number and divide it by the one before it. Now I'm going to be honest, I'm super lazy, so am I going to use the big numbers? Heck to the no. I'm going to come here to where they're smaller, and I can use mental math. Right? Because the ratio between the smaller numbers is the same thing as the ratio between the bigger numbers. All right? So this is kind of a situation of work smarter, not harder. Now, I did 12 divided by 48, which if you simplify that is 1/4. So there's my r value. So now let's write our formula. So to find this term, you take my common ratio, which is 1/4, and multiply it times the previous term. Remember to state what your initial value is. So my a sub 1, or my starting point, was 3072. The only other point that I need to make with you guys is recognize that these 1s and n's and n minus 1, these are all subscripts. All right? This is not telling you you're subtracting 1 from anything really. It's just saying to look one term back. Okay? So like, probably should have said it earlier, here's a sub n, here's a sub n minus 1, here's a sub n plus 1. So whenever it says a sub n minus 1, they're just saying take that number instead of this number. Okay? Also, like when kids see this notation in their brain, they're like, ooh, distribute that 1/4. There's some parentheses, there's something times it. This is a single value. Okay, this is a single number. You can't be distributing nothing. Don't be going crazy there. All right. But there we have it. That is how you write a recursive formula for a sequence, plus a little extra information for you. Until next time.